Hey guys, this is Coach McCullers. I'm going to do this video a little bit differently. You see here I have my graphic organizer in front of me, and here's my pen. So I'm recording this on my iPhone, so we'll see if we can get this to work. Okay? Alright, we'll start with the prime factorization. The definition of prime factorization is finding which prime numbers multiply together to make the original numbers. So I'm going to write that down. So we're finding what prime numbers multiply together to make the original. Okay, hopefully you'd read that. Finding what prime numbers multiply together to make the original. Okay, that's what prime factorization is. All right, we did some examples here in class, and I'm going to go ahead and do these. We did 40 to begin with. Okay, a little bit sloppy. My camera was in my way. All right, example of prime numbers that you can have are things like 1, 2, 3, 5, 7, ... Prime numbers are numbers that are only divisible by 1 and themselves. Okay, so let's do 40, the example 40 here. 40 breaks up into 2 times 20. 2 is prime. 20 breaks up into 2 times 10. 2 is prime. 10 breaks up into 2 times 5, and both of those are prime. So the prime factorization would actually be 2 to the third power times 5. And we put the 2 to the third power because it's 2 times 2 times 2. Okay? All right, the next example. Next example I'm going to do here is going to be 65. Okay, 65 breaks up into 5. Anything that ends in a 5 or 0 is divisible by 5. So 5 times what? I think we decided it was 5 times 13. And lo and behold, both of those are prime. So very easy. Usually write your prime factorization from the smallest prime factors to the largest prime factors. Okay? The last example for prime factorization is 128. Okay? Let's break it down. Now, you don't always have to choose prime numbers. You could choose something different. Say, for instance, you want to choose 16. 16, I think, goes into 128. 128 divided by 16 gives us an answer of 8. Neither one of these numbers are prime, so I still need to break them down. Well, 16 is 2 times 8. 2 is prime. 8 is 2 times 4. 2 is prime. And 4 is 2 times 2. Both of those are prime. So I broke the 16 down this way on the tree. On this other side, I still got to break down the 8. It's not prime. 2 times 4. This 2 is prime. And 4 is 2 times 2. Both of those are prime. So basically, we have a bunch of 2's here. 1, 2, 3, 4, 5, 6 2's. 3, 2, 4, 6. No, actually 7 2's. 1, 2, 3, 4, 5, 6, 7. So we write the prime factorization as 2 to the 7th power. Okay? Very good. All right, now move down. Perfect squares. Perfect squares are those numbers that have and that come out with a nice round number when you take the square root of them. Okay, so examples of perfect squares are 1, 4, 9, 16, 25, 36, 49. That's 7 times 7. 8 times 8 is 64. 9 times 9 is 81. And then we go to 100 and we keep going. Those are the perfect squares I want you to remember. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. Okay? All right. Well, I have a couple of rules already printed on here for you, and these are the steps for simplifying square root problems or expressions. And there's two choices. The first one is to do the prime factorization, what we just did before. Then find pairs. In other words, find two factors that are the same, two 2's or two 4's, or not 4, excuse me, two 5's. Rewrite the pairs as squares and then take the square root of the squares. Okay. The other method is to find the perfect square factors. These numbers that we just wrote up here, the 1, 4, 9, 16, 25 stuff. Rewrite the expression using perfect squares and then take the square root of those perfect squares. I'm going to do each one of these in an example down here. I'm going to call this method 1, and I'm going to call this method 2. Okay? So, in the first one, let's say we want to find what is the square root of, say, 40. Okay? We want to simplify this. If we work, in my notation, I always put a little hook on the end of my square roots just to show you where the square root ends. Okay? Now, if we try to put 40 in the calculator and take the square root of it, it's not going to be an even answer. We want to leave our answer with square roots. We want to make it exact and not rounded. Okay? So let's use method 1 here. All right, method 1 says, hey, break this down into the prime factorizations. Well, let's go back up above. 40 was 2 to the third power times 5. Now, the steps say find the prime factorization. Okay, here's the prime factorization, all these 2's and this 5. All right, and then step 2 says to find pairs. Okay, so this time when I write the prime factorization, I'm going to write 2 times 2 times 2. I'm going to write them all out, and then I'm going to do the times the 5. Okay, then that was step 1. Now step 2 says find pairs. There's a pair of numbers there. Okay, and then I'm going to rewrite it. So I'm going to rewrite it as 2 squared times 2 times 5. Okay, now remember, all of this is under the square root. Okay, there is a property of square roots that says when you take the square root of a product, you can separate these. Okay, so I'm going to separate the first one by itself and leave the last 2 together because they're not pairs. They're actually just going to stick together there. Now, this is the part that we focus on because when you take the square root of anything squared, you're just undoing the square. So the square root of 2 squared is just going to come out to be a 2. Okay, and then the square root stuff, 2 times 5, I mean, you could take the square root of 2 and then the square root of 5, but you're not going to be able to simplify them anymore. So what I'm going to do is I'm just going to put those back together and get 2 square roots of 10. Okay? So the square root of 40 simplifies into 2 square roots of 10. Nice. All right, let's do another example here. Let's say, excuse me. Let's say we want to find the square roots of 108. Okay. Now this time I'm going to use method 1 again. Alright, we did not do the prime factorization of 108 above, so what I'm going to do is I'm going to do the prime factorization. I'm going to do the factor tree. So I'm going to come over here to the side and say 108. That breaks up into 2 times 54. And then 54 is 2 times 27. And 27 is 3 times 9. And 9 is 3 times 3. So my prime factorization will be 2 times 2 times 3 times 3 times 3, or 2 squared times 3 to the third power. Okay. Now, all right, let's go back to the top, and what I want to do is I want to write the prime factorization out. 2 times 2 times 3 times 3 times 3. All right, that was step 1 of the process. This is step 1 of the process. Find the prime factorization. All right, the next step says to denote any pairs. Okay, there's step 2. We have 2 pairs here. Okay, and step 3 says rewrite those as squares. Okay, so remember, all of this is under the square root. So I'm going to rewrite these as squares. 2 squared times 3 squared times 3. Remember, don't put this 3 in with these 3's because we're thinking in terms of pairs here. Okay? So I'm going to take the square root. And then remember, the product rule says that if you take the square root of a product, you can separate them. So I'm going to take the square root of 2 squared times the square root of 3 squared times the square root of 3. Now the whole process of doing this is to get these square roots of squares, and you get out the answers. The square root of 2 squared is going to give me 2 times the square root of 3 squared is going to give me 3, and the square root of 3 is just going to end up being the square root of 3. Okay, but we're not done yet. Remember, you can get like terms together, and here the 2 and the 3 are like terms, and we can multiply them together. The square root's kind of like its own thing. You're going to hear me say this a lot. You can't mix oil and water. This is oil and this is water. You can't mix those, but you can put water with water and oil with oil. So you do need to multiply the 2 times 3 here and get 6 square roots of 3, and that is the simplified answer. Okay, so there's my work there. Method 1. All right, let me show you how to use method 2, and I'm going to do the same problem this time. I'm going to do 108, except for this time I'm going to use method 2. Okay, kind of hard to hold the phone while I do all this. All right, now, what method 2 focuses on is it focuses on perfect squares. Do you know of a perfect square factor that goes into the number? If you do, it makes your life a whole lot easier. I do know for a fact that 36 does go into 108. 36 goes into 108 3 times. Okay, this is the perfect square. All right, now remember the product rule says that if you take the square root of a product, you can separate it. Square root of 36 times the square root of 3. Well, the square root of 36 is very nice because the square root of 36 gives us the answer of 6. And 6 times the square root of 3 is exactly the same answer we got over here. So finding the perfect squares that go inside of here makes life a lot easier and makes your process a lot faster. Okay? Don't worry, you'll get more practice with this.